we know instantaneous rate. I told you in the last lecture that for the instantaneous rate, we should know either equation or slope of tangent, like this. I told you. Now for the instantaneous rate, today we have this to discuss some numerical problems. So the numerical problem or the question is N2O5 decomposes to NO2 and O2. The concentration of N2O5 at any time T is given by N2O5 at T is equal to 2 e to the power minus kT. Now calculate number 1, rate of disappearance of N2O5 at 10 to the power 3 second. And number 2, rate of reaction at 10 to the power 3 second. Dear friends, one value should also be given to you, the value of K, and given K is equal to 10 to the power minus 3 per second. This is the given value of K. Now we have to solve to this question. Here it is N2O5 at time T is equal to 2 into e to the power minus kT. Dear friends, there are some requirements for the instantaneous rate. I told you that either equation should be given or the slope of the tangent on the curve should be given. Here the equation is given, and my dear friends, here you have to calculate the rate at this point of time. So because a certain time is given, it means definitely you have to calculate, you have to know the instantaneous rate. This is not the question of the average rate, this is the question of the instantaneous rate. How we decide that this is the question of the instantaneous rate? This is by this time interval, time period is not given, exact time is given, pinpoint time is given. Since pinpoint time is given, exact time is given, that's why we can say we have to calculate the instantaneous rate. This is the given equation. So what you have to do, you have to differentiate this given equation. So differentiation with respect to t, with respect to time. So we can say here N2O5 dN2O5 upon dt is equal to, here we can say 2, and this is minus k, and e to the power again minus kt. So this is minus 2k and e to the power minus kt. Now dear friends, naturally you have a question how you differentiate this. Here I am giving you a little a small note. Suppose that here it is given to you y is equal to e to the power minus kt. So if you differentiate this dy by dt, then you can say dy by dt, then you can say minus k and e to the power minus kt like this, minus kt like this. This is the differentiation, the way of the differentiation, the method of the differentiation. So you should keep in your mind. Now dear friends, we can say we multiply the both sides, left hand side and right hand side with a minus. So we can say minus dN2O5 upon dt, and this is equal to plus 2k and e to the power minus kt. Now what is this value? This is rate of disappearance of N2O5. Now this is equal to 2k e to the power minus kt. Now dear friends, the time came for the putting the value. Given what? Given k is given 10 to the power minus 3 and second inverse. Here this k is given, it was given to you already, and the time is also given 10 to the power 3 and second. So put these value 2 into 10 to the power minus 3 and e to the power minus k. K value is 10 to the power minus 3, time value is 10 to the power 3. So you can say 2 into 10 to the power minus 3 divided by e. This is the one answer. It means you have calculated now rate of disappearance of N2O5. We should once have a look on this question. Dear friend, this is the question of the instantaneous rate. How we decide that this is the question of the instantaneous rate? Due to this value, exact time is given, pinpoint time is given. We have to calculate the exactly at this time, not over a period of time. This is the point of time, since this is point of time, not the period of time. This is not time interval. That's why, because this is point of time. So this is the question of the instantaneous rate. The second thing is little about the differentiation. If y is equal to e to the power minus kt, this type of equation is given to you, then dy by dt, this will be equal to minus k and e to the power minus kt. Now dear friends, when we this equation was given on the differentiation with respect to time, we get this type of expression. Now without any hesitation, we have to put the values, and this is 2 into 10 to the power minus 3 upon e. This is the answer. This is the answer. Now dear friends, another question was rate of reaction at 10 to the power minus 3 second. Here, for the rate of reaction, we have to write the correct stoichiometry. We have to write the correct stoichiometry. We can say 2N25 and 2NO2 plus O2. This is a possible stoichiometry. The second possible stoichiometry is N25 NO2 plus half O2. Now dear friends, This is the first stoichiometry. This is the second equation or the stoichiometry. Now, which one is correct? Now, dear friends, you should write a rule first. Here, you should write a rule. When the stoichiometry is not given in the question, then you should select that stoichiometry which has the least integers as stoichiometric constants or coefficients. So the rule is least integers. I am telling least integers. Here least integers. This is the fractional. Here everything is according to least integer. So this is the accepted stoichiometry. This is the rejected stoichiometry. Why, dear friends, this is the rejected? Because we know we should select that stoichiometry which has the least integers as the stoichiometric coefficient. Here there is least integer. This is not the integer, this is a fractional value, fraction. That's why we adopt this is accepted or adopted stoichiometry. This is the rejected stoichiometry. So everything we should do according to this. We can say rate of reaction, ROR, or rate of reaction. This is equal to 1/2 into rate of disappearance of N2O5. So we can say 1/2 rate of disappearance of N2O5. It was 2 into 10 to the power minus 3 upon E. Cancel it. This is 10 to the power minus 3 upon E. This is another answer. So dear friends, we should have a repeat revision look. By this question, we are just trying to understand the instantaneous rate. The first question is how we can say that this is the question of the instantaneous rate. This is the point of time, not the period of time. This is the point of time. Since we have to determine the rate at point of time, so it is very obvious, it is very clear that it is the question of the instantaneous rate. This equation is given, so you have to convert this equation into the rate. And dear friends, if you differentiate with respect to time, then you have this type of expression. If you multiply this right hand side and this left hand side by the minus sign, this one minus sign, then you will have this equation. And my dear friends, this is the rate of disappearance of N2O5. Now this is the equation of the rate of disappearance of N2O5. Now we have to put the values. This value was given, this value was given. We put these values and we get this one as answer. Now dear friends, for the calculation of the rate of reaction, what we should do, first of all, we should select the correct stoichiometry or the correct balanced equation. Stoichiometry is nothing but balanced equation. Dear friends, for this purpose, you should learn, you should remember a rule that when the balanced equation is not given by the column, then you should have to select to that balanced equation which has least integers. This has least integers. This is not integer. Half is not integer. So we accepted this one balanced equation and we rejected this one balanced equation. And on the basis of this one balanced equation, we can say rate of reaction is equal to half of rate of disintegration of N2O5. When we put the value of rate of disappearance of N2O5, then we have the rate of reaction 10 to the power minus 3 divided by E. Thank you very much. Thanks a lot.